Okay, so we begin today. We want to know the derivative of sine. And the derivative of sine, in order to prove that mathematically, I used to take everybody through that. It would take about 30 minutes to do. We actually spend just a whole class period proving the derivative of sine. We are going to do a non-proof, but kind of a justification or argument for what the derivative of sine is. So you don't have this in your notes, but I just want you guys to think about this for a second. I'm going to graph the derivative of sine on the same set of axes here. And how would you describe the slope right here? Positive, would you estimate to be about 1? Okay. How would you describe the derivative here? 0. How would you describe the derivative here? Negative 1. How would you describe the derivative here? 0. So it's interesting that if you look at the derivative of sine, you come up with, yeah, it turns out that the derivative of sine is cosine. Now that's not a proof, that's just a general argument, but if you were to just look at the graph and try to draw it, that's what you come up with. And so you see that in this situation we have these operators. It says d over dx. This is notation for derivative. So this means the derivative. So the derivative of sine is cosine. All 6 of these you need to memorize for the test. Okay. Now, some people are better at memorizing these, some people are not. I will share with you that there is a connection between the derivatives. If you can't find it, I'm sorry. I'm going to do my best. But whining about it and complaining about it won't help anybody, and I'll just think of you as a whiner. So the derivative of tangent is secant squared of x. So if you'd like me to prove it for you, I can.
I just like to know how. So it's just like this is that. Let's just accept.
Yep. Okay. We will prove 1 later on today, and it'll be rather short. The derivative of secant is secant of x times tangent of x. So in this situation, what I want you to understand is that yesterday you learned some important trigonometric formulas. Namely that sine squared plus cosine squared is 1. Notice how the derivative of sine is cosine. You also learned that 1 plus tangent squared is secant squared. Or secant squared is 1 plus tangent squared. See how they're not identical, but you see how the secant and the tangents pair up? Just like in that formula. And you also see how sine and cosine are paired up, just like in that formula. Now, what's interesting is the derivative of cosine is not sine, it's negative sine. And the derivative of secant squared, or the derivative of cotangent is not secant squared, it's negative cosecant squared. And the derivative of cosecant is not secant tangent, it's negative cosecant cotangent.
So cotangent is negative cosecant squared?
Yes.
And cosecant is negative cosecant times cotangent?
Yes. So another thing to recognize is that the derivative of all the cos are negative. If it's not a co, it's positive. You see that? So those are things that you could kind of relate. Multiple ways of figuring it out, but there we go. So let's take the derivative. Today we want to practice derivatives of functions that have trigonometric expressions within them. What's the derivative of negative 4x? Negative 4. What's the derivative of tangent? That's it. That's all there is. Nope. Sure. What's the derivative of sine? So anybody want to guess what the derivative of 3 sine is? 3 cosine. And what's the derivative of cosine? Negative sine, so we have minus 4 sine of x. That's it. So let's look at something that's slightly different. So Maddie's wondering where the trick is. When does it get more difficult? So this is where I will need your help. So I don't understand what people don't get about this part. And so people end up going on this test. They're like, I still don't understand how we do that. And I don't know how to explain it any better. So when I look at letter C, here's what I see. I see that the derivative of f of x, I take the derivative of 3x and I get 3 plus, and then I see x times cotangent of x. And so here's what some people do, and again, I don't get why, so you can help me out. People say, well, the derivative of x is 1, and the derivative of cotangent is negative cosecant squared. So that's a common thought. Okay. I ask myself, how do people not see that that's the product rule? We have x times cotangent of x. Do you see that? I mean, before, when we wrote this, when we wrote square root of x plus 1, and we took that times, say, x squared minus 3x plus 1, we did the product rule because you had a function with a variable times another function with a variable, so we did the product rule, right? Well, this is x times cotangent of x. So sometimes people do not recognize that. How we doing, buddy? Do you know the chicken dance? Do you want to do it? I'll do it. So let's go to work. I'm going to use the product rule in this situation. Yes.
So you know how like on the equation before, like
Yep.
4 cosine of x, why does that make it any different?
Thank you. Maddie asked an excellent question. And what she said is, in this situation, she says, why don't you have to use the product rule there? Okay? Can I show you? Let's just do the 3 sine of x. Okay? Can we just do that? Let's do the product rule once and see how it turns out. Notice that you have 3. We'll call that f, and we'll call sine g. And remember, the product rule is f prime g plus g prime f. Agreed? So what's the derivative of 3? 0 times sine of x plus, and then you leave f alone, which is 3 times, what's the derivative of sine? Cosine. And notice that this is 0, so it goes away. Notice how you get 3 cosine? So if it's a constant out front, I mean, if it's just a number, you don't have to use the product rule. But if there's a variable, then yes, you have to use the product rule. And so that's the important element to keep in mind. And we will do the product rule like 150 times in the next couple weeks here. So hopefully you'll get used to that piece. This is the first time you're seeing it. What's the derivative of x?
1.
Easton.
The derivative of x is...
Yes, 1. Very good. Times cotangent would be cotangent of x. Plus, then what? X times, what's the derivative of cotangent? Negative cosecant squared of x. So as we write this, we would have f prime of x is equal to positive 3 plus cotangent of x minus x cosecant squared of x. And that's it.
Where did you get the x and the cosecant squared?
Okay, so the product rule is f prime g plus g prime f.
Yeah. Okay, so you're just doing the product rule.
I'm just doing the product rule. Okay. All right, some of the calculus requires that it would be better if you remembered your trig. For example, for letter D, everybody would say we use what rule? The quotient rule. And I say, go ahead if you want to use the quotient rule, go ahead and do that. I say completely not necessary. Because what is 2 over cosine? It's 2 secant of x. The reciprocal of cosine is secant. So 2 divided by cosine is the same as 2 secant. So I rewrite this to be of this form, and then I take the derivative. What's the derivative of 2 secant? Yeah, 2 secant of x times tangent of x. And what's the derivative of 3? It is 0. No need to use the quotient rule. Just write it like that. What's that? So 2 divided by cosine is the same as 2 secant. The derivative of secant is secant tangent. Yes. You will get an answer that doesn't look the same, but it is the same. Okay. Yeah, I would just rewrite it every time. That's what I would do. Letter E. There is no way of getting around letter E. In this situation, you have to do the quotient rule. So let's go ahead and use the quotient rule. We'll call F the top, and we'll call G the bottom. And remember, the quotient rule is F prime G plus G prime F, all divided by G squared. I'm sorry, minus, thank you. So I have F prime of x is equal to, what's the derivative of the top? Cosine of x. Times what? X plus cosine of x. Minus, what's the derivative of the bottom? 1 minus sine of x times 1 plus sine of x. All over what? X plus cosine of x, quantity squared. So I'm going to see if this will simplify by distributing. I have the derivative of f is equal to x cosine of x plus what? Cosine squared. Let's focus on what I have underlined in blue. What is 1 minus sine times 1 plus sine? 1 minus sine squared, correct? So when we distribute the negative, what's going to happen? We get a minus 1 and we get a plus cosine squared. I'm sorry, plus sine squared. Sorry about that. Michaela, what you were saying earlier, that there's about 4 or 5 different ways to do the problem, that will work as well. I didn't want to skip to that because I didn't think people would see that as intuitively. So hopefully people see this. What do you see?
Cosine squared, sine squared.
What is sine squared plus cosine squared?
1.
So 1 and negative 1 will make 0. So you can see that this will all cancel out. And so therefore, f prime of x is equal to x cosine of x over x plus cosine of x, that quantity squared. No.
Well, that's
We good? Whoop. So this should be f prime of theta. The variable is theta, not x. Does anybody see what I'm supposed to do here? You could distribute secant, and it would require then the use of the product rule twice. Or you could just do the product rule right now. Okay, so we will call this f, and we will call this g. What is the derivative of secant? Good. Secant of theta times tangent of theta. Times what? Theta plus tangent of theta. So that's the first part. Plus, then I leave this alone, don't I? So secant of theta times, and now Marissa's taking the derivative of theta plus tangent of theta, which is? Good. Because the derivative of theta, that's like the derivative of x. Okay? So we would like to see if there's anything that could combine for like terms, and we'd like to see if maybe there's some type of special trig identity that would work itself out. So we're going to have to distribute here a little bit. So f prime of theta is equal to, and please focus on this because people do get lost during this part. I take that times that, and I get theta times secant of theta times tangent of theta. Everybody okay with that? Yep, exactly. And then I take it times this, and I will get plus a secant of theta times tangent of theta squared. Is everybody okay with that? Plus, then I'm going to distribute that, and I get secant of theta plus secant cubed of theta. Good. I don't see any special trig identity, but one way in which you could try to find a different trig identity is to, what do you notice about all the terms they all have? They all have secant, so let's try factoring out secant. I factor out the secant, and I have theta times tangent of theta. What is your next part that you're going to have? Plus tangent squared of theta. Plus 1. Plus secant squared theta. Is there somebody out there who can tell me what is 1 plus tangent squared? Secant squared. So this piece becomes secant squared. So what do you get if you take secant squared plus secant squared? 2 secant squared. So f prime of theta is equal to, we have the secant times theta tangent of theta plus 2 secant squared of theta. That's done. Where did what go? This thing? So tangent squared of theta plus 1 is the same as secant squared. This thing right here is the same as that. So if you add those together, you get 2 of them. Okay? That is the answer. That's the answer. Shh. Okay, this next part, write an equation for a line. In order to write an equation for a line, you need how many things? Slope and point. We need those 2 things. Okay? What is the x value at which we are trying to find the point? Pi over 6. Okay? So I have pi over 6, and then how would I produce the y value? I would plug it in, and I now need to know the sine of pi over 6. What is the sine of pi over 6?
1/2.
So, for those who maybe weren't here yesterday, those who need the review, pi over 6 is how many degrees? 30. That makes this coordinate right here, root of 3 over 2, and 1/2 is sine the x value or the y value? It is the y value. So you have the sine of pi over 6 is 1/2, and 1 minus 1/2 is 1/2. Great, we've got that piece. In order to find the slope, what do you have to do? Take the derivative. Fortunately, we know how to take the derivative of things like that. It's quite easy. What is the derivative of that function? Negative cosine. Once we know the derivative, we can then find the slope at pi over 6. All we have to do is plug in pi over 6. What's the cosine of pi over 6? Yeah, notice as I've drawn this angle of pi over 6, or 30 degrees, I have this terminal point. The y value is sine, and the x value is cosine. So therefore, we know that the slope is negative root of 3 over 2. Is that enough information to write the equation for my line? Yeah. So the rest is just basic algebra. Whether or not we can do that, we'll see. Y minus 1/2 is equal to negative root of 3 over 2 times what? Okay, so we got some fractions going on here, right? We're going to put it into slope-intercept form so we can see what the slope is and we can see what the b value is. So I'll distribute negative root of 3 over 2. So y minus 1/2 is equal to negative root of 3 over 2x plus pi roots of 3 over 12. Now what? Add the half, so y is equal to negative root of 3 over 2x plus, and so if we add a half, that's going to be adding 6/12. Everybody agree? So I get pi roots of 3 plus 6 all over 12. It is. That's almost an identical problem to what we would say is one of the easier problems you'll see on the AP exam. So coming up with those pieces is definitely something we want to be able to do. Okay. Flip it over. Yes?
Where did we get the slope? The derivative of
Yeah, so in order to come up with the slope, we find the derivative, and when we find the derivative to be negative cosine, we plug in pi over 6. So we've already produced the angle of pi over 6. We know that the cosine is the x value. Better? Okay. So we're going to prove right now. It's very short. It's quite easy. Some of you still have that. You got to get your brain all the time where every time you see proof, you think just negative, bad, impossible. The great thing about proofs is you know the start and you know the answer. We know the answer. So it should be easy. We just got to get from one to the other, right? So we're going to prove that the derivative of cosecant is negative cosecant cotangent. So Marissa brought up a good point earlier. Why does it work? Well, as long as we accept this one thing to be true, that the derivative of sine is what? Cosine, then we should be able to prove all the other formulas from that. Now, if you want to see why that's true, I gave you the graphical argument. If you want to see the actual proof, you can tune into a different video. Check out the proof of the derivative of sine using the sandwich theorem. That's a real thing in mathematics, the sandwich theorem. But let's do that. So here we go. So I'm going to take the derivative of cosecant of x. So that's what I start out with, and I want to end with the other thing in red. Okay? So in my transition, I will do the blue things. Well, I don't know anything about cosecant, but I do know something about sine. So I can rewrite cosecant as 1 over sine. So I have 1 over sine of x derivative. So that's great because I do know something about sine. And this is in the form of something where I could use the quotient rule, right? So let's use the quotient rule here to find this derivative. What's the derivative of 1? 0 times what? Sine of x minus, now I do the derivative of the bottom, which is sine. So the derivative of sine is cosine, times what? 1, all divided by sine squared. So all I've done is just use the quotient rule. What do you have left in the top? So on the top I have negative cosine of x. And what do you have in the bottom? Sine squared of x. So now you feel like you're kind of, stuck. All we have to do is just look at the ending, and say, well, that's what we want to come up with. And now it'll kind of tell us what to do next. What is cosecant? 1 over sine. So let's write it like this. Let's write negative 1 over sine times. So all I've done is I factored the negative off and one of the signs out. So what would be left? Cosine over sine. So we're almost done. Let's make sure everybody sees it. Does everybody see why negative cosine over sine squared is the same as what I have right here? I've just factored it apart. What's that? This part? This part. So I'm using the quotient rule. The quotient rule says the derivative of 1 is 0 times the bottom minus the top is 1 times the derivative of the bottom, which is cosine. This guy? This is what we want to come up with. You're proving that that is equal to that. To that. So do you see that negative 1 times cosine is that? And then on the bottom, sine times sine is sine squared. We're good? Okay. We're basically ready to end the proof. Can somebody tell me what is negative 1 over sine? Negative cosecant of x times what is cosine over sine? Cotangent of x. So we are done. As you can see, we started with the derivative of cosecant. All the stuff in blue is what we substituted in to make our argument. We ended up with negative cosecant cotangent. The proof is done. This part? So what I did is I took negative cosine over sine squared and I factored it into 2 parts. So negative 1 times cosine is negative cosine, and sine times sine is sine squared. Okay. You're not going to be able to? Okay. Your opportunity to start your worksheet, derivatives of trigonometric functions. Go.